technologies. So I'm gonna start showing briefly about the company. So I work for AM. So we are a family brand. We have different brands like at Avis, Earth Network, FTS. So those different brands have a different specialized field. So for example, View, that is the software of the company. FTS is more fire. We support our customer in flood warning, dam leaf safety, reservoir operation, floodways. I remember a couple of days ago that someone asked me about how we can protect a road. And I said that we can use cameras and also we can use like a gates. But he asked me, how are you gonna know? How are you gonna alert the people? I say, okay. The way that we did it, we use AI just to use the camera and to see if something changed in the environment. So see that the water flow is increasing and is covering the road. The system automatically can send an alert and just close the gate. And also the system can send an alert to the people. So the people in charge, the customer, they can check it if it's really that is happening, it will happen, activate it manually. But if nobody's there, because sometimes the disaster or something like this happen at night, the system automatically can close it and alert the people around it. And how we do it? We do detection, prediction, planning, mitigation, and response management. We have a completely design and implementation system. So we have the sensing. So we have all the station. We send the data using different telemetry options like Alert 2, Inmarsat, GOES. We receive the data and we have the software that is elementary 60 to process all the data, to clean the data, because for us it's important to have a really quality data. So the data is important. So sometimes the station can fail, we can send bad data. It's important to clean that kind of data. So we have that in our software. We have GAR, that is the radar. We can just keep it historical data that we use it to predict, to forecast. We have the decision support that Element 360 allow the customer just to customize, as I said before, when we have some threshold, they activate the alert, activate the sirens, or send message to the community. And as I said before, Element 360 is the program that we use it. The program where we manage all the stations, different stations, not just the float station. We can manage also the fire, cameras, and everything. What is important that alert is customers, so we can set up a different threshold. We can trigger an alarm for any sensor or group of sensors within your software data. And also we can do analysis with the data. You can add any equation that you needed. So with the information that you have it, if you want to calculate something different, you can add that equation and the system, the program is gonna calculate it for you. And also I was talking minutes ago about that now you don't have to go to the field to know if your station is working well or not, because the system is going to say, okay, if you are receiving bad data or the system is down, that means that you have to go to check it. So you can see from the website, from the program, that some of the stations need maintenance, and also you can do scheduled maintenance using the program. And also the program, we have forecast model. We use B-flow to model and having a high resolution float prediction. Those are an example of radars, one in bridge, one in the site, and rain gauge, weather stations, the loggers that we have it, and the communication, the telemetry options that we have it. And also we have gauge network installation and maintenance that we provide mainly here in USA. But when we have a large project around the world, our company go to the site, to the place, to the country, but we don't do the process. We teach the people there to the company to know, we provide the know-how, how to install the software, how to do the maintenance. So at the end, they are the people that know the station. So we have experience in large international projects like Peru, that is the one that I'm gonna present today. We have a project in Australia, we did a project in Bangladesh and other projects. So the Peru, now we did the design for all the Peru that is gonna protect all the Peru. So we start with a consortium with different companies, 4 companies to start the project. You know, in Latin America, we have El Niño y La Niña. So in Peru in 2017, El Niño caused severe flooding and damage to the country infrastructure. So what the government wants just to protect the people, and they need a guidance to know how really monitoring the flood and to protect the community. So that is the early warning system. So we have the different basins. After the analysis that we did, those are the more critical basins in Peru. So here we have the model. So we have the radar, we have the telemetry option. So we have GOES, we have the VHF. So mainly in Peru, we use VHF. So we use Alert 2 for the design, but there are some areas where we can access with VHS. So we use GOES, we use also Inmarsat. So you know that GOES is free, but the issue that has GOES that is transmit every hour. So we need to use, in some cases, use Inmarsat to transmit the data. And also we have a meteorological station and hydrological station. If you see here, we have ADCP, so that both. So we need, where we install the hydrological station, we need to measure the crop section of the river to have, to enable to calculate the discharge. With the discharge, we can model the area that is gonna be flooded around that station, and with that model, we can set up the alarms that we need to protect the community. And also we have the local center where are the computers. There are a regional center, and we have a national center that Peru needed. So, and also we have the sirens. So when something is gonna happen, the system, we can activate the system manually, or we can activate the system automatically just to sound the sirens and just alert the people that something is gonna happen in the area. We have 4 components there in Peru. The first one was to identify the risk areas. So we use the hydrological and solid movement analysis. Then we have the second component that was the monitoring, that we have radars, rainfall, stream flow, soil moisture was using to predict landslide. And also we have weather, mass movement, and the 2 more are the risk and the decision support. Mass communication, so we have the cell towers to communicate, so we can send the message to the community, but we use also the sirens. Why the sirens? Because there are some parts in Latin America, in Peru, that people maybe don't have signs in the cell phones, or maybe they don't use the radio, they don't watch the TV just to know that something's gonna happen. So sirens help to the people to be alert that they need to get out of the area. And also, I remember one case in Colombia that all the disaster happened at night. So when you are sleeping, you don't want to wake up just to watch your cell phone and say, oh, it's coming. No. So the sirens is the best way just to communicate to the people that they need to get out of the area. So the sirens, as I said before, you can, the people in charge can activate manually, and also they can be activated automatically. And also we have the response component where we have the emergency response plans, evacuation plans, and public awareness. That is the overall concept of the design. So we had the sense, the station, the radar, the rainfall, the stream, the land motion. So all the data collecting, processing. We have the guard that receive information from radar, gauge rainfall station. For predict model, we have the data that the model needs is rain, stream, and flow, and land flow. And all that information is sent to SENAMHI. That is the main entity in Peru. So SENAMHI have local places and the national places. So we send the information to two places, local and nationally. And then people there can take, they can activate the system manually. They can send message, they can alert, and also they can activate the sirens, depends on the case. That is like the same, how differentiate between region and nationally. The components, subcomponents, the risk area, the monitoring, the mass communication, the response. And that was the first analysis that we did it. So we create using GIS maps to analyze the hydrological zones of inundation. So we can see on the map what are the areas that are more likely affected with that one. So we have very high, medium, and low, and the same we did for mass movement. With that kind of information, we overlap and we find the areas of the subbasin that we need to be protected. Here we have the finally selection of the watershed that we want to use it, the location of the radars, so we can see the location of the radar they need to cover all the subbasins, and we have an example where we're gonna locate the station like a rainfall, streamfall, weather, and line seismic stations. Radar is a really important part in the process to predict, because with radar we can get rainfall information, and also it's important for Peru because Peru is a coastal country, so we can deploy a station, precipitation station in the sea. So we use radar to get information for that part. And also GAR use the radar information and also the rain gauge information to improve the data, so improve the precipitation information. Here is one example of land station and another one in the river. So we use solar panel. There are a lot of sun there in Peru, and also different telemetry options based on the condition that those are located. Here is the radar. If we see the right side is uncalibrated weather data, and the next one is the calibrate radar rainfall. So the calibrate use rain gauge data. So GAR combines data from both rain gauge and weather radars to produce more accurate rainfall product as compared to rain gauge and weather radars alone. Here is one example that how you can see how is behavior the discharge in one of the stations. So we have different colors of, so for example, when we reach the yellow one, we can set up the model to send a message to the people in charge, to the people that is just checking the condition of the river. For the second one, we can send the message for the people that in higher level, and we can send message just to the community that be prepared, that they need to evacuate. And for example, with the red one, we can send message just to the community that activate the sirens and is the moment to evacuate. And here is one example that how you can visualize and in Element 360, how they can help you to take decisions and to see the models. And in mass communication, here is how is the national servers, the regional servers connect to the sirens. So it's a redundant model that from national or from regional, we can activate the sirens. Here we can see the designs of the sirens, how was designed just to cover all the areas, and how we can use real parameters like a background noise, like a wind, building intensity, how there are some barriers that can reduce the noise, so the noise of the sirens. And finally, the component 4, that is an important part because it's the community. So we need to teach the community how they need to evacuate, where, what is the process. So we need to do workshops, community exercise drills that they know, they recognize the sounds. They can know, they recognize what is gonna be the message that they're gonna receive. So, and also we need to work what kind of message we're gonna send to the public. I remember a couple of days ago that say, we can send a message really, really long that the people don't gonna read it. But if we send it a specific message, like one means that you need to be ready. Second, you need to go right now, get out of the area. So that is something that we need to work with the community and also with the stakeholders. And then those are the stakeholders that are involved in the project in Peru. So there are ANA, SENAMHI, those are the water sector in Peru, and coast, core are where are the center, and so on. So that show all the stakeholders in Peru. Thank you so much. If you have any questions, just let me know. Other than that, you know where we are.